Could the future of resource extraction lie beyond the confines of our own planet? As we stand on the brink of a new era, we're starting to ask serious questions about a field that was once the realm of science fiction. Space mining. The concept is as exciting as it is complex. It revolves around extracting valuable resources from celestial bodies such as asteroids or the moon. And why is it important, you ask? Well, our dear Earth is not an inexhaustible source of resources. As demand continues to grow, we need to start considering alternatives. Space mining offers a potential solution to Earth's resource scarcity. It could provide us with rare elements, water and helium-3, a potential fuel for nuclear fusion. But that's not all. It may also hold the key to financing future space exploration. As we gaze upon the stars, we may be looking at the future of mining. The idea of extracting resources from celestial bodies is not as new as one might think. The concept of space mining has been floating around in the realm of science fiction for well over a century, with authors and filmmakers imagining brave pioneers venturing out into the cosmos in search of valuable minerals and gases. It wasn't until the mid-20th century, however, that space mining began to shift from the realm of fiction into the sphere of possibility. The successful launch of Sputnik by the Soviet Union in 1957 marked the beginning of the space age and opened up a new frontier for exploration and potential resource extraction. The following decades saw numerous advancements in space technology, from the moon landing in 1969 to the deployment of robotic explorers on Mars. These feats not only increased our understanding of the solar system, but also hinted at the possibility of utilizing these celestial bodies for resources. In the late 20th and early 21st centuries, the potential for space mining began to be seriously considered. In 2001, a company called Planetary Resources was founded with the ambitious goal of mining asteroids for resources. This marked a significant moment in the history of space mining, as it represented a shift from government-led space exploration to private sector involvement. Technological advancements have also played a crucial role in the progress of space mining. Developments in robotics, artificial intelligence, and space travel technology have made the idea of extracting resources from asteroids, the moon, and even other planets increasingly feasible. It's important to note, however, that we are still in the early stages of space mining. While the technology and interest are there, many hurdles remain, including technical challenges, legal issues, and ethical considerations. But regardless of these challenges, the potential benefits of space mining, such as providing a solution to resource scarcity on Earth and potentially fueling further space exploration, are too significant to ignore. From a mere dream, space mining has evolved into a field with real potential. So where do we stand today in the realm of space mining? Well, we're witnessing the dawn of a new era. Space mining is no longer just a concept, it's a burgeoning industry that's pushing the boundaries of what we once thought possible. Companies like Planetary Resources and Deep Space Industries are leading the charge. These pioneers are developing technologies to explore, extract, and utilize resources from asteroids and other celestial bodies. They're not just planning to mine the stars. They're already testing their spacecraft and honing their techniques. Take Planetary Resources, for instance. Their Archied 6 spacecraft was successfully launched into space to test prospecting technologies. It's a small but significant step towards the future of space mining. Meanwhile, Deep Space Industries is working on developing spacecraft that can not only identify asteroid resources, but also process them in space. Their concept of a water-propellant microgravity foundry could revolutionize space travel by allowing spacecraft to refuel in space, drastically reducing costs and expanding possibilities for exploration. In a similar vein, Luxembourg, a small European nation, is making a big name for itself in the space mining sector. The country's government has launched an initiative to establish a legal framework for the ownership of resources obtained from space. They're also investing in research and development and attracting companies to set up shop in their borders. And it's not just private companies and governments. Universities and research institutions worldwide are involved too. They're studying everything from the potential impact of mining operations on asteroids to the best ways to extract valuable resources like water, platinum, and palladium from space rocks. It's clear that space mining is not just about the quest for resources. It's about pushing the boundaries of human knowledge and capability. It's about finding new and innovative ways to sustain our way of life and fuel our pursuit of the stars. The quest for celestial resources is no longer a thing of the future, but a reality of our time. Opening. As we navigate this new frontier, what does the future hold for space mining? The future of space mining is a thrilling prospect, teeming with endless possibilities. Picture this. We could be extracting rare elements such as platinum or palladium from asteroids or the moon. These metals are not only valuable, but they also have numerous applications in various industries, from electronics to aerospace. But the potential products of space mining don't stop at rare elements. There's also the tantalizing prospect of mining helium-3, a potential fuel for nuclear fusion. Unlike Earth, the Moon is abundant in this isotope, making it a prime target for future space mining missions. Now, why is all this important? Well, space mining could be the answer to many of Earth's pressing problems. As our planet's resources deplete, space mining offers a solution to resource scarcity. It could provide us with the materials we need to sustain our technological advancements and economic growth. Moreover, space mining could transform the economics of space exploration itself. The resources mined from asteroids or other celestial bodies could be used to build, fuel, and maintain spacecraft right in space. This could significantly reduce the costs associated with launching everything from Earth, making space exploration more feasible and affordable. But it's not just about economics. Space mining could also contribute to scientific knowledge. By studying the resources extracted from asteroids or the moon, we could learn valuable information about the formation and evolution of our solar system. Of course, realizing this future won't be easy. It will require technological advancements, massive investments, international cooperation, and the development of a legal and ethical framework for space mining. But the potential rewards make it an endeavor worth pursuing. Closing. The potential of space mining is as vast as the universe itself, but with great potential come great challenges. What are the ethical and legal implications of space mining? The first hurdle is ownership. According to the Outer Space Treaty of 1967, no nation can lay claim to any celestial body. So, who has the right to mine asteroids or the moon? Some argue that space resources should be a shared heritage of mankind. Others contend that property rights are essential to incentivize exploration and development. Next, we have the environmental impacts. It's easy to dismiss concerns about damaging lifeless rocks floating in the void. But consider this. Mining operations could inadvertently alter the orbits of asteroids, posing a potential collision risk. And what about the pollution caused by mining and processing activities? We've seen the damage done by unregulated mining on Earth. We certainly don't want to repeat those mistakes in space. Then there's the question of international cooperation and regulation. Space mining is a global endeavor that transcends national boundaries. It requires a collective effort to establish regulations that balance the interests of all stakeholders. That includes not only the mining companies and their investors, but also future generations who will inherit the consequences of our actions today. Moreover, there's a need for transparency and accountability. Mining operations must be monitored to ensure compliance with regulations and to prevent any harmful effects. Implementing such oversight on a global scale is no easy task, but it's essential to prevent conflicts and ensure a sustainable future for space mining. Lastly, we must consider the social implications. Space mining could exacerbate wealth inequality, with rich corporations reaping the benefits while the rest of humanity foots the bill. It's crucial to ensure that the rewards of space mining are shared equitably, contributing to the betterment of all mankind, rather than just a privileged few. As we venture into this new frontier, we must navigate not only the stars, but also the complex ethical and legal terrains. As we have seen, space mining presents a world of opportunities, but also a universe of challenges. From its humble beginnings to its current state, space mining has the potential to revolutionize our approach to resource extraction. It's not just about precious metals and minerals. Water and helium-3 from celestial bodies could fuel future space exploration and even solve resource scarcity here on Earth. Yet, as we venture into this new frontier, we must also grapple with complex ethical and legal issues. Who owns these celestial resources? How do we mitigate environmental impacts? These are questions that demand international cooperation and regulation. Looking forward, asteroid, moon, even Mars mining beckon with promise. The potential benefits are staggering, but so too are the risks and uncertainties. As we stand on the brink of this new era, the question remains, are we ready to mine the stars?